So this transformation maps this transformation where Z0 has a restriction that the imaginary part has to be greater than 0. So Z0 is some point above the real axis, and psi is just some real number. So this will map the upper half plane onto the interior of the unit circle and the unit disk. So I've actually just seen an example of that where Z0 was I and psi was 0. Obviously we have lots of such transformations because we could choose our Z1, Z2 and Z3 to be any 3 points along this line, and we can choose our W1, W2, W3 to be any 3 points in a line around this circle, and they would all generate different Z0s and so on, or in different psis. It's quite easy to see why this is true. If we take the modulus of both sides, we get modulus of this is just 1, so we can remove that. So suppose Z is here. So we've got the Z0 we've said is some point above the imaginary axis. Above the real axis. So for any point Z, if that point is above Z0 is here and Z0 star is a reflection. So all we're saying is we're comparing the distance of a general point Z from Z0 to the distance to Z0 star. So you can see that if a point Z is above the real axis, this distance here, which is this quantity here, will be less than this distance here, which is this quantity here, and therefore mod W will be less than 1. So this point here has to get mapped to a point inside the circle. If we're on this line, if we're on the real axis, then the distance between these mirror images will be the same, which means this equals this, modulus equals this, and we're somewhere on mod W equals 1. And if we're at a point here, this distance here will be larger than this distance here. This will be larger than this, and we'll be outside. So it's easy to see and remember this formula in that way.